Alright, so you did a bunch of stuff with trig identities and stuff like that this chapter. Learned lots of new ones, and now we're gonna put them to use solving equations that have trigonometric functions in them. So this is 7.6 and it's on trigonometric equations. Which means equations means it has an equal sign in it, which means you're solving for something. Usually, we are solving for the angle here. Angle, and I'm gonna say angles that solve the equation. I can't think of any other times offhand that we're not, but as soon as I say some shit like that, I will, like, the next thing I do is flip the page and be like, oh yeah, I forgot about that. So let's just start off. Let's do 3 tangent theta minus square root of 3 equals 0. And if it helps, I'm gonna show how we would do this if it was not a trig function, but just a regular algebra equation. How would we solve the right hand one?
Add square root of 3 both sides.
We would add the square root of 3 to both sides. And we would get 3x equals square root of 3.
Square
No.
Divide by 3.
Divide by 3.
We wanna get x by itself. I can see why you would want to with that square root there. But the square root is not on if the square root is on an x, we would square it. But we really just wanna get 3 by itself, and we don't care if the answer is ugly. Because, and this is widely unknown to a lot of students. Most of the equations you had when you were taking algebraic classes and shit like that were catered to have nice little clean answers. But in reality, shit ain't clean. It's never exactly fucking 20 feet long. It's 20 feet 0.00052, some shit like that. Real life doesn't have whole numbers, not usually. Not unless you're doing some basic shit like, how many apples can I buy for $1 if they're 25 cents each? Well, let's do that same process over here. We'll add the square root of 3 to both sides. And then we'll divide by 3. So the same process all the way up till this point. And this is where the tangent inverse or the inverse part comes in from 7.5, so I guess there's a little relation, but. There's another way of looking at this. So there's 2 ways we can do this. One way would be, let's say, we take tangent inverse of both sides. The inverse of a function and a function wipe themselves out and they always leave the argument. In this case, theta. But almost invariably, every time you're doing inverse things in trig, unless you're. Like there's derivatives and shit going on in calculus. Easier way to approach it is just say, or. What angles theta would make tangent of theta equals square root of 3 over 3. Lewis says 30 degrees. Are you guys good with that? Why do you have to think like you're looking at me like this is a trap? He's like blurted out an answer, like, do you guys think that's right? That is true, tangent of 30 degrees is square root of 3/3. However. It is not the only angle that does that. Oh, reference angles. What reference angle also has square root of 3/3? 210. In fact. Oftentimes in the homework problems, you will see the following setup. They will say. In 0 degrees to 360 degrees. And then B, it will say all solutions. And you'll be like, well, what the fuck? That's true, this is, what else is there? Those are the only 2 degrees in 0 to 360 that work. But remember, we're going around in a circle, and every time we hit the thing again on a circle. We get back to where it was, so for all solutions, it's gonna be 30 degrees. Plus 360 degrees times. Some number n, where n is a whole number. And then we could say 210 plus 360 degrees, n. N is gonna be an integer. Integers are the numbers your countable numbers, your 0, 1, 2, 3, dot dot dot, but it also includes the negative numbers. But no decimal places, no well, if it's a fraction, it's gotta simplify that a whole number. Sweet. But pictorially. 30 degrees is there. 210 degrees is that angle. This is 180 degrees. 210 minus 30 is 180. And we know a full circle would make another 100, or make 360, 180 plus 180 equals 360. So I could actually condense this down. These can condense down to 30 degrees plus 180 degrees times that. Now, both are technically correct. I don't know if the Hummer is gonna. Act like a little bitch and say one of them is right and the other is wrong, but. If you do it and like you double check your work and they're like, no, this works. See if you can do something like you can make it where it's just one line rather than two. This is a valid solution, I would take that on. On test. So we solve it like we do an algebra equation. We get it down to a trig function equals something, and then we figure out what angles work. Seem fair? Sure, everyone's getting right on the correction page, two people still writing. Alright. Anybody need that longer? Okay. So with that in mind. How would we go about solving something like this? Cosine theta, cotangent theta. Equals negative cosine theta. Over the interval, we'll do just 0 to 360 for now. Any ideas? Alright, let's go with what Louis said, divide by cosine theta, you said? Okay. We'll divide both sides by cosine theta. And I'm gonna get cotangent theta equals -1. Where does that hold true? Man, this has got his shit down. Right? We'll add 180 to it, don't have to do it in your head, add 180 to it, 315. So 135 and 315. Those two angles definitely work. And yet, that is not the answer. Lewis unbeknowingly broke a cardinal rule of mathematics. I was hoping someone would. Because by making the mistake in class, maybe you'll remember it and not do it when it matters. What can we never divide by?
0.
Can cosine theta ever equal 0? And if cosine theta equals 0 here, would it solve this equation? We'd have 0 on the left, we'd have 0 on the right, it would solve this equation. So. He has actually eliminated some answers by dividing by something that actually works. A better way to do this is add cosine theta to both sides. And then we factor out cosine theta. Now, this is kind of like having x times x plus 1 equals 0. Well, there are different x's here, but like same idea. How would I solve that in algebra? You're going with the, I think you're going with the right idea.
The outer x, you would multiply it with the inner one? No.
Well, that just puts us back to where we were.
Yep. Just
What? So when you have two things multiplied together and they equal 0, what has to be true?
One of us was 0.
One of them has to be 0, right? I have this is multiplied by this. So one of them has to be 0 if it equals 0. We don't know which one, so we're gonna set both of them equal to 0. X equals 0 or x plus 1 equals 0, and then you solve individually. We're gonna do that here. We're gonna say cosine theta equals 0 or cotangent theta plus 1 equals 0. I didn't write equals 0 on the left. Said it and didn't write it. Now, I'm gonna do the right one first, cause you'll see if I subtract 1 from both sides here. I get cotangent theta equals -1, which is what we had up there. And we get the two answers that Lewis came up with fairly quickly. But we also got the two that were destroyed by dividing by cosine theta. This also has to equal 0. What angles theta make cosine equal 0? Remember, cosine is related to the x value.
Pi over 2.
Pi over 2 is one of them. 3 pi over 2. Now, since we've got 1 in degrees and 1 in radians. They actually asked for degrees, so let's put our answer in what they asked for. These are correct in radians. what would this be in terms of degrees? 90 and 270. So those are the 4 degrees that will make that answer true. And what if you think Mr. Jones is full of shit?
And double check the one.
How? You're right,
Plug in.
just plug it in.
Yeah.
Plug each of them in. Cosine of 135. Go back to the very initial equation. There's a negative here. What is cosine of 135?
Or negative.
It's negative root 2 over 2. And that means this side has a negative and then a negative root 2 over 2. And Lewis already told us that was -1. So this is positive, when you multiply them out, you get positive root 2 over 2 equals positive root 2 over 2, it makes a true statement. And you can do this with each of them and find out that yes, in fact, all 4 work. That is one of the best things about mathematics in general. Almost every single thing that we do. You can actually check to see if it actually, like if you're ever solving for anything, you can just plug it in and verify. Did it actually solve it? Now, in this case up here, it won't tell you that you missed it. But you can make sure that the ones you got do work. So, if something can equal 0. Don't divide by it. Cause you just might be destroying some valuable information. Was that fun? Sneaky fucking question. It's easy to do, it is so easy to make the mistake. Of just dividing, cause that's how we solve a lot of shit. Just get rid of that, yeah, simple, let's clean it up, let's get rid of things that are on both sides. If they could possibly equal 0, don't do it. Hope that doesn't make Lewis stop answering questions. He's doing good. So right, yeah, the answer you gave were right, that's correct. Everyone ready? If you need that longer, say something, but. Good, Spencer? Things moving, okay. I never know if students making additional notes or doodling or what, so I wanna ask. Alright, next fun one. Ooh. 3 sine squared x. Minus sine x. Minus 2 equals 0. Any ideas? What? What'd you say?
It's a factor, but I wasn't finished looking at it.
Well, we will do that, that is actually the correct answer. But most people won't recognize it as the correct answer. So. If shit looks weird. What I'm gonna do is I'm gonna say, just to make things a little bit like, let's get rid of the trig function for now. Let's substitute the letter U in for it. So this, when sine is squared and u equals sine, we would have 3u². Minus sine x, that's u. Minus 2 equals 0. And now we have something that's a quadratic equation and we can factor. We have algebraic rules for doing that. It's probably been a while. So if I have. I'm not gonna use x, even though that's what we normally use, I'm gonna use u here, because that's what I got in the equation. If we've got something like that. What we wanna do is look for two numbers that multiply. To a times c. But add. To b. Well, a here is 3. B is the number in front of u, which is -1. And c is the number without a u, which is -2. So a times c would be -6. And b equals -1. -1. Two and 3 are the right numbers, one of them's gotta be negative though. -3. We put the 2 and the -3 on there, that should work. Now, if you've forgotten how to factor, I'll put up an announcement on with a little video on how to do it. There's a lot of shit going on in factoring. But like this is like the most complicated form to factor, really. And I've got a nice little handy method you might like, but we don't have time for it in here, except maybe when we're done. So when we do that, when we factor that. 2 and -3, they don't just go into parentheses, what we gotta do is, we're gonna break the negative u up into plus 2u. And then minus 3u. And then minus 2 equals 0. And then we group. Sets of 2. And factor out what we can in each one. Here, I could factor out a u, and if I factor out a u, I would have 3u, not u time or equals. I would have. U times 3u plus 2. And if I have done it correctly, I should get another 3u plus 2. And I will get that if I have a -1. Well, negative, so I can factor out the negative sign, but I don't want to just leave the negative sign hanging, so we're gonna put it with a 1. Some of you algebra might have been a while ago. At this point. This is one term, this is one term, we again factor out the most or the thing in common. They both have a 3u plus 2 in them. And what's left over goes in its own parentheses, u minus 1 equals 0. Now, it's a good idea, especially if you got the time before you continue. Multiply it out, make sure you actually get what you started with. So 3u times u would be 3u². 3u times -1 would be -3u. 2 times u would be plus 2u. And 2 times -1 would be -2. And if I combine the things in the middle, I do get what I started with. So I did factor it correctly. But now that we know it's factored correctly, we have two things that are multiplied equal to 0. We'll set them each equal to 0. And you don't have to do it now, but now is a good time if you actually put in a u instead of factoring with sign in there. Replace the u with sign real quick. That way you don't forget that's what we were doing. In fact, I could have replaced it right up there. I could have said 3 sine x plus 2 times sine x minus 1. I could have done it there. That never even needed the u. You are really good with factoring. It's easy to fuck that up though, so like if you do it without making a little substitution, always multiply back out, make sure you got the right thing. At this point, we saw them. I will subtract 2 from both sides here. And divide by 3. So I get sine x equals -2/3. Or we'll add 1 to both sides here. And that's what we're looking at, sine, these are our 2 things. Do we have something on the unit circle that gives us an answer to this one? If not, this is where you gotta use the inverse thing. So I'm gonna take sine inverse of both sides here. I'm gonna get x equals sine inverse of -2/3. And if you can't do it on the unit circle, you're not gonna be able to do it without grabbing a calculator. My sine inverse is directly above my sine button. I'm gonna do shift sine inverse. I'm gonna put it in parentheses, -2 divided by 3. And I'll say equal. And I got it, oh, that's in radian mode. I'll fuck it. Now I'm gonna change it to degrees. Degrees is easier to make sense out of. -41.8 degrees. So if I look on a unit circle. That means we're going backwards. 41.8 degrees. That's really a reference angle. The other spot sine would have that same reference angle would be over here, sine needed to be negative. We had sine x equals -2/3. Sine would be negative here if we go back negative. Or if we go 41.8 degrees there. So we gotta figure out what those two are on 0 to 360. This one, the one on the left is 180 plus 41.8. Which is 221.8 degrees. And I'm rounding to 1 decimal place. This one is probably easier to do 360 minus 41.8. 8. And what do I get? 318.2. I'm doing that in my head. But now I don't feel confident, so I'm gonna go ahead and calculate. 318.2. So that gave us this one. What about where sine x equals 1?
That's actually.
Loud and proud, what do we got? What about 270? 270 would be -1, 270's out. So. Our final answer is gonna be 90 degrees, 221.8 degrees. Or 318.2 degrees. Unfortunately, if you stick those in a calculator, those are not gonna be exact because we rounded. But they should be very close to working. Plug it in, you should get really close to 0. me give you guys one. Let you work on it for a little bit. Let's say cosine squared x. Plus, what do I wanna go with? 7 cosine x. Plus 12 equals 0. This one definitely factors. The next one we'll do together does not factor. But this one factors.
Really helpful if you change it into algebra rather than just factor it the way it is. So yeah,
Right, yeah, rewriting it as
if I
algebra,
didn't know, I would just start factoring it like that, but yeah, when you change it to algebra, it makes more sense.
so if you were to change to algebra here, what would you do?
I would just put x squared plus 7x plus 12 equals 0.
I recommend not using x.
You.
So you,
Because, and this is the only reason, because we already have x in it. If this said theta, go ahead and use x. But don't, like, if there's an x in it, don't use the same letter, that'll fucking confuse you. Cause you'll see an x and you'll forget, so I would do with that. That knowledge. It fucking turned hot all of a sudden.
yeah,
Like a couple days ago, it wasn't fucking hot, and yesterday, it was like. The afternoon, it's pretty fucking warm outside. Got in my car at 2 o'clock today, and it said fucking 97 degrees, I'm like, god damn, the fuck?
it's only
March."
today, it's gonna come down.
Yeah, I know, it's just like a sudden fucking heat
I know
wave.
it went up like crazy today.
Do you not know how to do it?
Yeah, it's just not, I have it entered correctly, it's just not letting me. That I'm on my next form or something, so maybe I'm not entering it.
Interesting.
Yeah, I'm not. putting it in. And then when I click enter. It's giving me this, stop. What is it? Something.
Let's change this to secant x. Make it secant squared x plus 7 secant x. Because we were getting cosine x equals 3 and cosine x equals 4, and those aren't valid numbers. Cosine goes between -1 and 1. It was literally outside the range, that's what, your calculator's not wrong, I just gave you shit that doesn't solve.
-3 and -4, right?
Yeah, if you ended up doing it, yeah. This is what happens when you wing it, you just make up shit in the spot. But I know secant x will work. Actually, makes it a little bit harder too. Get a bitch.
You can flip it upside down.
Yes,
And then keep it inverse.
you flip it upside down, you'll have cosine x equals negative one
Okay,
third,
now
cosine
I'm
x
back
equals
on
negative
track
one
here.
fourth. Yeah, I think you had +3 in your calculator too.
I had -3, I was
You
just
had
trying
negative,
negative and positive to see maybe if I was just,
Okay.
if it would work.
No, it was right.
So what?
So when you factor this, you're gonna get. U plus 3 times U plus 4 equals 0, you might have them in the opposite order. But you're gonna end up getting. U plus 3 equals 0 or U plus 4 equals 0. The problem with cosine is when you solve these, you're getting U equals -3 or U equals -4. But cosine theta does not equal -3 for any value theta. So we could have gone with no answer. There's no angle that works, but rather than doing that, I'd rather like. Switch it to secant. So if we use secant, now we've got secant x. Equals -3 or secant x equals -4. And secant is 1/cosine. And. Could like cross multiply, or the fancy thing is just flip them. And we get cosine x on top here. And the -3 flips over and it's -1/3, because -3 is the same thing as -3/1. So when we flip that bad boy. And we flip this bad boy and we get -1/4. From David.
Yeah,
Yeah, it's not the wrong thing.
so like 120 degrees is cosine -1/2. So is it kind of, you're working from there to find -1/4? Or -1/3?
We're much better off just going with the calculator at this point.
Inverse.
Yeah, cause like, so. What Dave is saying is like -120, which is right about there. Gets us, this would be like -1/2 if I did it correctly. But we're looking for like -1/3 or -1/4, which is over here. What angles does that match up to? It's not gonna be one on our circle, our unit circle. So like. We're definitely gonna wanna do calculator. Need 2 decimal places because it's a large number on the in one.
I was in radian mode, it's like 1 degree, 1.9 degrees.
Yeah, when I get something low like that, I always, if it's
Yeah.
close to 1. Or 0, I make sure that I'm not in. So this is an interesting difference between cosine and sine. When we do sine inverse. It goes to -90 or to +90. So the angle is always a reference angle. But on cosine. Cosine does 0 to 180. Cosine inverse. So it's not giving us necessarily a reference angle. It's giving us the actual theta. So it is actually telling us how far we're rotating to get these values. But quadrant 2 is not the only spot cosine is negative. Yeah. Also in quadrant 3.
Oh.
So we've got one of them going to, I don't know, 140 degrees. I don't know what this angle is. But we gotta go that far this way to do the same thing there. So it's kind of like going back this way would be 104.48. And we really want to figure out this one. Or an easier way that might be more helpful to look at it. So if we're doing the 104.48, we're like that. And cosine is also negative down here, and we want this angle too. This would be our reference angle, and this should be the same angle. So we can figure out what this one is. This one, our angle right here should be 180 plus whatever we get for theta hat. And we can figure out theta hat. Because we know these two have to add up to 180. Right? A half a circle is 180. So if I subtract. I'm getting theta hat equals 75.52 degrees. I'll put that in here. That T55. So far, we've got 104.48 and 255.52. We also had the 109.47 degrees, and it's gonna do the same thing that the 104 did. Gerardo's like, fuck, this is a lot of work, fuck all that, I can see it in his face. I agree, so fucking, it's a lot. And yet, the trig identity fucking shit in 7.2 is harder. This is doing that angle, we wanna find the reference angle there. So that we can do the reference angle here. So we're gonna say theta hat plus 109.47 equals 180. Subtract. $70.53. I think I'm doing that in my head.
Yeah.
And then this one is 180 plus that. Should be 250.53 degrees. So our other two angles, I'll put them up here so they're all together. 109.47 and 250.53. And let's take a 10-minute break before we dig into the other parts of these. Alright, let's go with this one. Cosine x times cosine x plus 2 equals 1. What should I do here?
Subtract the ones. Potentially found.
I was hoping someone would do the wrong answer first. That's correct. We actually want to subtract the 1. We cannot do the whole set each side equal to 1, because that property only works with 0. If we want to do it where we like set each thing equal to 0, it's got to be 0. So we really got to subtract the 1 over, so let's like distribute first. If I distribute, I have cosine squared x plus 2 cosine x. And then if I subtract the 1 from both sides, I got -1 equals 0. And if it helps, let's put in u equals cosine x. How long do you want me to let you try to factor that before I tell you that is not factorable?
Yeah, I realized by the 2 cosine x and then go over the u, I was like, oh no.
So, what you may have forgotten, it's probably been a while, the quadratic formula.
Yeah.
So when you have something that isn't solvable, we're still doing that AU squared plus, fuck, I wrote it twice. AU squared plus BU plus C equals 0. We can jump straight to U equals negative B plus or minus the square root of B squared minus 4AC all over 2A. You can actually derive that from this equation. If you're good with your algebra and know how to complete the square. In fact, if you wanna see how to do it, I'll put up a video. Every time I teach algebra, I do it. I don't just hand out the equation like a formula. We go through it. Now. If you struggle remembering it, here's a stupid way to remember it. There was a negative boy. He was such a square, he was undecided about going to this party. And so he missed out on meeting 4 awesome chicks. The party was over at 2 AM. So negative boy was undecided, so the different signs. You just gotta remember, there's a way to remember the square root, I said it wrong, but either way, he was such a square, boy squared. He missed 4 awesome chicks, awesome chick. All over 2 AM, over 2 AM. I liked it when I heard it, but I just fucking mangled it. You're welcome.
It does help, but.
So, what are A, B, and C here?
1, 2, and
1, 2, and -1. Let's drop them in. Alright, what do we got on the inside there? 2 squared is 4, and I got 4 times 1 times -1 is -4.
plus 4. Basically.
So it ends up being 4 plus 4. I actually got square root of 8 on there, right? I'm gonna leave it as 4 times 2 inside for a second. It's really square root of 8, but. As a reminder, if it's been a while, properties of square roots, I can write square root of 4 times 2. Equals square root of 4 times square root of 2. And square root of 4 is 2. So this could be really 2 root 2. So u equals -2 plus or minus 2√2/2. If I pull out a 2 out of everything. This would be -1 plus or minus 1 square root of 2. And I could have the 2 there. And the 2's can cancel at this point. So u equals. And this ends up being two things, when we have the plus or minus, this really means -1 plus square root of 2, or u equals -1 minus square root of 2. That's what the plus or minus does, it breaks it up into two solutions. We good? That's not the answer. It ain't about you. It's about that. Well, you gotta put that back in. So just cleaning that up a little bit, getting a decimal real quick. This actually will help. We still need to do, this is not the angle, I'm just doing -1 plus square root of 2, and then I'm gonna do -1 minus square root of 2. Now what?
Inverse function.
Inverse function. Do I need to try to do this on both? Which one do I not need to do it on and why? This is outside the range. So this is not valid. So that one can go fuck off. So x is gonna be cosine inverse of that. And rather than doing that, I'm gonna use the original one where I didn't round. Cosine inverse of that. I'll round here, so you'll probably get the same thing. 65.5 degrees,
That's not that.
that's, well, cosine is. Somewhere in here. In this case, it happens to be the reference angle, if it's less than 90, it's the reference angle. We saw in the last problem, it's not always. That way, like when we had the 104, that's not a reference angle. So we can also get this by going 65.5 that way.
So the range is 1 to -1. Yeah.
This is.
Yeah. Cause remember, and y'all just got done graphing this. When you graph cosine. The max value is 1 and the smallest value is -1. I can't get a -2.4 on this graph, no, anywhere. So we'll have 65.5 degrees. And what is that, 360 minus that? $298.5, am I doing that right in my head? No, minus 65 is a lot less than that,
294.
294. I had 60.5 in my head for some reason, 61.5. And then, as a reminder, if we wanted any solution. We could say 65.5 degrees plus 360 times n. Or 294.5 degrees plus 360 times n. Next problem. Cotangent x minus square root of 3 equals cosecant x. And this time, let's go 0 to 2 pi. Let's do radians this time. Well, I don't want to, we already talked about not dividing by shit that might equal 0. So another way that we can go about doing this. Is something David wanted to do earlier is. That's. The cotangent, do we have formulas that have cotangent and cosecant in them? That we did in this chapter?
There's one that's like cotangent squared theta plus 1 equals cosecant.
Cosecant squared. So. If I square this. I would get a cotangent, I would get cosecant squared, and I could write it in terms of cotangent. So that's what we're gonna do. Let's square both sides. This one is don't just square the things individually. That is this on the left. On the right side, we can just write it as cosecant squared x. Put that off the side. So it doesn't look like a part of it. If I distribute here, I have cotangent squared x. Minus square root of 3 cotangent x. Minus square root of 3 cotangent x. And then square root of 3 times square root of 3, both of them negative turn into positive 3. This is a great question for Baker.
Yeah.
What does that turn into?
It's -2 squared. Square root of 3.
See, you learned.
Yeah.
Alright, now we're gonna do what David said. I know that equals cotangent squared x plus 1. I'm gonna put that in. Well, we don't like having shit that's the same on different sides, so. I'm gonna move everything to the left by subtracting the shit on the right. And conveniently. Cotangent squared goes away. Two. Y'all with me so far? I just got rid of Victor from doing homework. He stopped doing what he's doing, he's paying attention now. Like I got called out of nowhere. Alright, how do I solve this? Okay. Q is the only thing that factored out. It's valid. What do I do with it now? It's gonna happen eventually, so doing it now works just fine. Can I get rid of it by dividing by 2? Is that a valid operation? We're not dividing by 0. 2 can go fuck itself. And 0 divided by 2 is 0. Now what? We wanna solve for x, so we're trying to get x by itself, in this case, we're gonna get cotangent x by itself first. Subtract 1 from both sides. And then divide by negative square root of 3 on both sides. And we get cotangent x equals 1 over square root of 3. Which is square root of 3 over 3. What x's does that work for? If you can do it in degrees, do it in degrees first, then we can convert. Yeah. It is. Is that the only one? We go around, we get one, another 180 would be 240. What is that in radians? So close. 5/3. And that will be 4π/3. Now, I'm gonna point out something to you, so hopefully this will be a way to remember it and why it's true. If I just had something where I said y equals 2. And I square both sides. I would get y squared equals 4. But when you take the square root of both sides. I would get y equals plus or minus 2. What I started with was y equals 2, and now I have y equals plus or minus 2. When you square. Squaring introduces potentially. They're called extraneous solutions.
Is that the reason why it's positive right there?
What?
No, I just had a question like, why it went from negative to positive?
Where? Here or here?
No, yeah, right there,
Cause we had two negatives.
so it's not a negative fraction,
No, it'll end up being a positive fraction.
it ends.
Cause we had a negative one on the right and we had it, they were both negative. Another way to do this is if I had added. Cotan or square root of 3 cotangent x to both sides,
Mhm.
and then you would see that everything is positive there. It ends up being because we had a negative here and a negative here and two negatives cancel
I
out.
thought about doing that too, like adding a square, so we could get rid of the. The root, but like, yeah, I understand what it's supposed to be.
Okay. The idea, where I was trying to go with this is, the only answer was y equals 2, but when I squared it. The solution introduces a -2 as a possible answer, because. -2 squared does equal 4. So by squaring it, we introduced an answer that didn't work. Which means, that's what extraneous means. It means like an extra solution that's not right. It's a long word for fucking like error. So what it means is you gotta check your solutions. So we're gonna go all the way back up to cotangent x. Minus square root of 3 equals cosecant x, and we're gonna check our work in there. We'll check the pi over 3. So cotangent of pi over 3 minus square root of 3. Does that equal cosecant of pi over 3? Ugh. This is rough. Cotangent of pi over 3. Cotangent of 60 degrees. Well, we know what that was. We said that was 1 over square root of 3. Right? Or square root of 3 over 3. So I got square root of 3 over 3 minus square root of 3. Does that equal, well, what is cosecant? Pi over 3. This is 1 over sine of 60 degrees.
Is it 2√3 over?
Should be 2 root 3 over 3. Because this would be 1 over square root of 3 over 2. And we multiply top and bottom by that. We get 2 over root 3, which is 2 root 3 over 3. So is this true? Well, let's multiply this by 3 over 3. Thumbs off. Am I missing a sign here somewhere? Doesn't work. This is -2 over root 3 on the right, the left side, right? Pi over 3 is out. Let's check the 4 pi over 3. Now, the good thing about this shit is it's gonna be the same numbers, we just gotta check whether they're negative or not. So this is still gonna be a root 3 over 3. And if I have a common denominator like that. The question is cotangent positive or negative at 4 pi over 3? What quadrant is 4 pi over 3?
3.
Is cotangent positive or negative there? It's positive, so we're gonna leave that one positive. What about cosecant? We said that was 2 root 3 over 3. Is that positive or negative in quadrant 3? It's negative, why? You look so uncertain of that.
Did the ASTC.
That works, the easier way to think about it is 1 over sine, and sine is negative there, that goes with the ASTC. And now this ends up being true. So 4 pi/3 was the only valid answer. So let's develop like a strategy for tackling this shit. Solving a trigonometric equation. So step one, decide whether it is linear or quadratic in form. Quadratic means there's squares present. Linear means no squares present. If there's only one trig function, solve for it. And this means go all the way down to find out what the angle equals. Don't just get it down to cosine x equals something. Find out what x equals. If there's more than one trig function present. One thing you can try is rewrite the equation. Where one side equals 0. And factor. We did that on the cosine x. Cotangent x. Equal cosine x, we did it on that one. Yeah, I had it line so. If that doesn't work, try using trig identities. See if it cleans up. And the last stage method would be maybe. Try squaring both sides. But if you do, you check for extraneous solutions. 4. If it's quadratic. It's called a U substitution, if that helps. Substitution. And factor. If possible. Or use quadratic formula. Got 2 more problems we're gonna do. I'm sure there was more lecture pages on this. You'll see what we tell out. Let me just pause, let's just try this. Then I'll go on. So the more stuff in this section is doing double angles and half angles. I'm not gonna do half angles, the homework might have half angles. I already told you I'm not testing you on half angles, fuck half angles. They're pain in the ass, they're not worth. It's doing the same thing as double angles, you just gotta use the formulas. But the double angles show up a hell of a lot more often in calculus, so we're gonna focus on that. So like, our next question is gonna be. Solve cosine of 2x. Equals sine x. Now I have 2 different trig functions. Which sucks. Can I rewrite one of them in the form of the other? What does cosine 2x equal in terms of sine x?
It's like both, right? There's a cosine and a sine.
Yeah, that's why I'm confused.
Cosine of 2x has 3 different versions.
There's a 2
Oh,
cosine x, sine x.
There's a 2 cosine, no, that's
They're talking about
sine of 2x.
2 sine squared x minus 1.
There's a 2 cosine squared x minus 1. There is a cosine squared x minus sine squared x. And there is a 1 minus 2 sine squared x. And we got sine on the right side, let's use that one. Now I hate working with negative squared terms. So rather than moving everything to the left, I'm gonna move everything to the right. But you can do it the other way. If you want. -1 and then plus 2 sine squared x. I get 0 equals 2 sine squared x. Plus sine x. -1. I absolutely detest having it where it's the other way and if you move the sine x over, you're gonna have both sine x and -2 sine squared x. And it's just harder to fucking factor when the square term isn't positive, it's just hard to factor. It's easy to fuck up the sign. If it helps, let's say u equals sine x. And do this as 2u squared plus u minus 1 equals 0. Does that factor?
Two plus one.
Needs to multiply to a times c would be -2. And add to 1. There's really only two options here. To multiply to -2, we could do. -1 and +2, or +1 and -2. Those are the two options we have. So that we multiply to -2. The only one that's gonna work here is the add to 1 would be that one. So I'm gonna write sine x. Oh. I was doing u. We're gonna write positive u as -1u plus 2u. U is splitting into that. And then we had -1, that's 0. Group them up, pair them up. This one I can factor out a u. And this is already 2u minus 1, so. I can put this as +1 times that. I strongly recommend you keep writing equals 0. If you don't, you're gonna forget it's there. And you're not gonna solve, it happens a lot. I know, it's writing down shit that's already there, but trust me. You may not do it every time, but you will eventually forget that you started with an equation if you stop writing the equals. This factors into u plus 1 times 2u minus 1. And we split them into, I'm gonna put the u equals sine x plot, sine x back in. Do these in radians too, give you guys the practice. We get sine x equals -1 or sine x equals 1/2. What does x equal here? Well, that'll be this one. What about -1? 3π/2. This one doesn't have a reference angle, it's on the axis, but this one is a reference angle. Where else does sine x equal π/6 or 1/2? Gotta be sine x is y, it's gotta be positive on both. Quadrant 2 would be 5π/6. So those are our three answers, π/6, 5π/6, or 3π/2. One I really wanna cover with you because it's got something, it's got a twist. That we haven't done yet. So we're gonna go 2 cosine squared theta minus 2 sine squared theta. Plus 1. Equals 0. Having cosine squared and sine squared is a pain in the ass. So let's factor out the 2. On that one, and we'll still have +1 equals 0. What does that equal? No,
B, or is it cosine? That's. You got me.
it just did it, it's cosine. Cosine of 2 theta. So if we solve for this, cosine of 2 theta equals -1/2. Now, if you do it this way, I mean, there's other ways to do this problem, but if you do it this way. It gets down to a nice formula quickly, but let's say we're doing degrees. If we say 0 is less than theta, which is less than 360 degrees. What is gonna be the range on 2 theta? Multiply this by 2. And you get 0 degrees and 720 degrees. So where does cosine, let's just ignore the angle for now. We're gonna go up to 720 degrees. Where does the angle of cosine equal -1/2? Where was it equal +1/2?
It's 30 and then 150 is -1/2.
Nope. That's sine is 30 is 1/2. Cosine of what is 1/2?
150.
It would be like a 60 degrees, so we'll go, if it's negative, it's gotta be -120 degrees. So we're over here with a reference angle of 60 degrees. Which means we're also doing cosine here, this is a reference angle of 60 degrees. So, not -120, +120, where the fuck did I get the -120? Let's go, we're going to do 0 to 720. So I've got 120 and then I've got 240. And if I go another lap around, like the 120 is gonna be 120 plus 360. I would have 480. And if I add 360 to the 240, I get 600, right? That equals the argument of cosine, which was 2 theta. We didn't start with theta, or 2 theta, we started with theta. So to get back to theta. We're gonna divide everything by 2. Theta will equal 60 degrees, 120 degrees, 240 degrees, and 300 degrees. What?
As it's 2 theta up to 720 degrees, that's why you have to.
Right. There is another way to solve this. Cosine squared is 1 minus sine squared. So I have 2 minus 2 sine squared theta. Minus 2 sine squared theta. Plus 1 equals 0. Or -4 sine squared theta plus 3 equals 0. If I subtract 3. And then divide by -4. I get sine squared theta equals 3/4. You take the square root of both sides, you get sine theta equals, square root of 3 doesn't change, square root of 4 is 2, but it's plus or minus. So we want everywhere that sine has a value of square root of 3/2, whether it's positive or negative. And that is a 60-degree reference angle. And a 60-degree reference angle will generate us. Since it's plus or minus 60, 120, 240. Or 300. Couple ways to do it. But if you, sometimes it's easier to switch to the double angle. When you switch to the double angle, just remember to double your range. So we solved that 2 different ways, got the same answers. I know, there's a lot to unpack there, it takes, yeah, it isn't something that like practice helps. That's why we get homework. Right?
Yes, no, you're totally correct. It's an information overload.
If you wanna see what you got on the test or see what you did wrong on the test, check your email. There's a link, it says grade scope, click on the link, you might have to register with a like a student email. But then like it's everything was scanned in, so everything that was wrong, it's written on there. Or it will tell you like the little gold points of what was marked out.
I need a.
And I will see you guys on Tuesday.
I didn't.
Take mine first.